Our second section on sequences is on arithmetic sequences and series. An arithmetic sequence is one in which each term after the first differs by the preceding terms by a constant amount. Okay, that's the difference between arithmetic and geometric that we'll do next. The difference between consecutive terms is called the common difference. So it says D is equal to A sub n minus 1 minus A sub n. All that's saying is, say, the second term minus the first term will give you the common difference, or the third minus the second, or the fourth minus the third, or so forth. This is the formula to find a general term, any term of an arithmetic sequence, where you have the first term and the common difference. So if you have the first term and the common difference, then you can plug in, and if it's the 10th term that you want, you would plug in 10 for n. So let's look at an example. It says, determine whether the sequence is arithmetic. And if so, identify the common difference. So all we're going to do is start with the second term and subtract the first. And we get 2. Then the third term and subtract the second. And we get 6. So we can already tell, since these differences are different, that it is not an arithmetic sequence. Looking at part B, we'll do 9 minus 4. And then the third term minus the second. And let's keep trying just to make sure we don't, nothing changes here. So fourth minus third. And fifth minus fourth. They all give us 5. So yes, this is an arithmetic sequence. And the common difference is 5. Example 2 says, write the first 4 terms of the arithmetic sequence whose first term is 6 and whose common difference is -5. So, if the first term is 6, then the second term is just 6 minus 5. The third term would be whatever 6 minus 5 is, so let's go ahead and find that out. It's 1. So it'll be 1 minus 5, which is -4. And then the fourth term will be -4 minus 5, which is -9. So those are the first 4 terms, 6, 1, -4, -9. And then it says to find the 9th term. So we know that A sub n is equal to A sub 1 plus n minus 1 times d. So A sub 9 would be equal to the first term, that was 6, plus n minus 1, and n is 9, times the common difference, which is -5. So that gives us 6 plus 8 times -5. Which will be -34. Another example says, find the 40th term of an arithmetic sequence in which A sub 1, or the first term, is 12, and A sub 11 is -38. So in order to find the 40th term, using A sub n equals A sub 1 plus n minus 1 times d. So far we've got the first term and we've got n, but we don't have d. So we need to find d, and we can do that using our formula and the fact that we've got A sub 1 and A sub 11, and that'll allow us to find d. So back over here, we're going to use the same formula with these two terms to find D. So a sub 11 was negative 38. A sub 1 is 12. And since we're looking at a sub 11, then n here is 11. And then we're just going to solve our equation for D. So we've got and I'm going to bring the 10D over here and subtract 12 from 38. That gives us negative 50. So D is negative 5. So that's what we're going to plug in right here. And now we can find the 40th term. And that is negative 183. Find the first 6 terms in this arithmetic sequence, in which a sub n is 100, and a sub n equals a sub n minus 1 minus 30. So what this is it's telling us each of the next terms. For example, a sub 1, and that should be a 1 right there, is 100. I'll change that on my paper too. So, a sub 2 is the previous term, 100, minus 30. A sub 3 is the previous term, which was 70, minus 30. A sub 4 is the previous term, 40 minus 30, so 10. A sub 5 is the previous term, 10 minus 30, gives us negative 20. And a sub 6 will be negative 20 minus 30, which is negative 50. So the first 6 terms are 100, 70, 40, 10, negative 20, and negative 50. So not so bad so far, right? Example 5 says, find the number of terms in this finite arithmetic sequence. So we can see here that we've got the first term, and we've got the last term. And we want to see what is in for that last term. That will tell us how many terms there were. Our first step is to find D. And we can do that by looking at those first 3 terms. So we'll take 8 minus 3, that's 5. And 13 minus 8, that's 5. So D must be 5. So if we look back at our formula, then we've got our final term, which is the a sub n we're looking for, 98. We've got the first term, 3. We don't have n, and we have that D is 5. So now all we're doing is looking for n. So let's see, subtract. Let's go ahead and distribute. That'll be 5n minus 5. So 5n minus 2. Add 2 to both sides. And divide by 5, and we get 20. So A, that tells us that a sub 20 is 98. So there must be 20 terms in this finite arithmetic sequence. Example 6 says the data in the graph show that in 2010, 16% of the U.S. population was Latino. On average, this is projected to increase by approximately 0.35% per year. Write a formula for the nth term of the arithmetic sequence that describes the percentage of the U.S. population that will be Latino in N years after 2009. So, back to our formula. We know that a sub 1 is 16. We don't know n minus 1, but we know that the difference is 0.35%. And why am I not changing that to a 0.0035? Because we're using 16% and we didn't change that decimal, so we won't change this one. You could do both, but we're just using it as, instead of treating it like a percent, we're treating it like just a number. So we can simplify this to get 0.35n, I've just distributed and added common terms, plus 15.65. So that is our formula for finding the percentage after n years. Now it says what percentage of the U.S. population is projected to be Latino in 2030? Well, the initial year was, it says, in years after 2009. So n will be 2030 minus 2009, or 21 years. So we're trying to find a sub 21. So we just plug in 21 for n, multiply, add, and we get 23%. And again, we don't have to change that percent from a decimal because we didn't to start with. Another thing you need to know, the sum of the first n terms of an arithmetic sequence. So you want to find how, if there's 4 terms, what would the sum of those 4 terms be? So this is a formula you can use for that. S sub n, S stands for sum, and n is however many terms you're wanting to sum. So S sub n is n over 2 multiplied by a sub 1, the first term, plus a sub n, whatever your last term is going to be. So 7 says, finds the sum of the first 15 terms of this arithmetic sequence. Well, we don't know what the 15th term is. So the first thing we're going to have to do is find that. We've got, back to our formula, a sub n equals a sub 1 plus n minus 1 times d. And we're going to be looking for a sub 15. We've got the first term. We've got the n is 15, but we don't have d. So we're going to have to back up here and find d. So let's see, 6 minus 3 is 3. 9 minus 6 is 3. 12 minus 9 is 3. So it looks like D is 3. And we'll plug that in here. So subtract, multiply, add, and we get that 45 is the 15th term. So we want to know the sum of the first 15. Let's write down the general formula first. S sub n is equal to n over 2 times a sub 1 plus a sub n. So we want S sub 15 because we're looking for the first 15 terms. So 15 goes on top. A sub 1 was 3. And A sub 15 was 45. So you'll have 3 plus 45 is 48. Multiply that by 15 over 2, and you get 360. So that tells you that the sum of the first 15 terms is 360. Little bit different way of notation here, but the same idea. It says find the sum of the finite series where the sum from k equals 1 to 22 is 8 minus 5k. So remember in the previous section we talked about this E thing. It means summation. And so we're going to use that to help us find the sum of the first 22 terms. Now we could go through this and plug in 1, 2, 3, 4, 5, all the way up to 22 and add them. That would take a lot of time though. If we're going to use our formula, then we need to know the first term and the last term. Okay? So, to find the first term, we'll just plug in. So a sub 1 would be 8 minus 5 times 1, or 3. So we can put that in there. And if we're going to find, let's see, the 22nd term, I think it'll work out this way, where we don't have to find D. Then we'll just do 8 minus 5 times 22. And that gives us negative 102. So we can add here, give us negative 99, multiply by 11, and we get negative 1,089. So the sum of this series is actually a negative number, negative 1,089. And our last example says an outdoor amphitheater has seating in concentric semicircles so that the first row has 11 seats, the second row has 16, the third has 21, and so on. So we've got, like, there's your first row with 11 seats. There's your second row with 16. There's the third, and you can see how the rows get longer so that you can have more seats. How many seats are in the last row if there's 24 rows of seating? So, let's see. We're going to need to know at some point what is A sub 24. If we look at our formula, we know A sub 1, the first row, had 11 seats. And we know N is going to be 24. But we need to know what D is. So to find D, we had 11 for the first, 16 for the second. So we'll do 16 minus 11 gives us 5. 21 minus 16 is 5. So D must be 5. So then we can find A sub 24 just by plugging in that 5, subtract, multiply, add. We get 126 seats. And that concludes our next to last section of the class.